Hello, this is Mr. Johnston. We're going to talk about multi-step conversions where we're going from particles to mass. So when we go from particles to mass, we know that we cannot go straight from particles to mass. We know that we have to have a conversion factor. And the conversion factor we're going to use is moles. So we know that 1 mole is 6.02 times 10 to the 23rd particles. We know that 1 mole can also be 202.4 liters, but 1 mole is also the molar mass of an element or a compound. So let's take a look at what we have here. It says determine the mass of 8.4 times 10 to the 27 molecules of Na3P, which is sodium phosphide. So we are going to write down our known, which is 8.4 times 10 to 27 molecules of Na3P. And we are looking for the mass in grams. Okay, so we can't go straight from particles to mass. We have to go through moles. So let's set up our logic path. So we have particles, we have moles, we have mass. So one thing we have to figure out here for mass, first things first, we need to find the molar mass. So let's break down what we have. We have sodium and we have phosphorus. But we have 3 sodiums and we only have 1 phosphorus. So now that we have this part, now we need to look up and figure out the molar mass. So on the periodic table, sodium is 22.99 grams and phosphorus is 30.97 grams. So now we can do some math with these two. 22.99 times 3 is 68.97. And 1 times 30.97 is 30.97. Add these two together, and you get 99.94 grams. And that's going to be grams per mole. That's the gram molecular weight. So now we have that part. Let's work on our logic path. Well, we have our logic path. And so we need to have 3. So that means we have 3 brackets. We're not going to use the bottom one. So let's exit out. Particles, because that's what we're given. Moles, because that's what we can get through. And then mass, and we're going to put that in grams. So we've got the top. Now we have to do the bottom. Same thing goes to the bottom, but it's 1 over. Particles, mole. We're looking for grams, so we don't need to go any farther. So now that we've got our units in, we can do our substitutions. So we are given 8.4 times 10 to the 27 molecules of Na3P. particles, we know the conversion factor for particles. 1 mole, 6.02 times 10 to the 23rd. And then we have to take in molar mass. So 1 mole is going to be 99.94 grams. So we have our brackets filled in. This is math. Let's cancel out our likes. We're left with grams, which is the unit we were looking for. Now we can set everything up. Now this is still a fraction. So let's go ahead and make our bar. Open parentheses, because parentheses make math a lot easier. 8.4 times 10 to the 27 times, there's nothing here, so we don't have to worry about that one, but there is a 99.94 grams here. Close parentheses, because if you open a parentheses, you got to close it. Then we're going to drop down. 6.02 times 10 to the 23rd. We have all of our substitutions done. Now it's time to work some calculator magic. In these calculators, when we do scientific notation like this, you can do 8.4 times 10 with the caret, but it does not necessarily work the right way all the time. So we have a easier way using the second function, which is the blue button all the way at the top, and the comma. If you look at the comma, which is right above the 7, you see 2 little e's. That stands for exponential equation. So I'm going to show you how to do the steps. Turn your calculator on, open parentheses, 8.4, second function, comma, 27. When you hit the comma, it gave you a little itty bitty little e. That stands for exponent, and the exponent is going to be 27. Then we're going to be multiplying by 99.94. Then we're going to close parentheses, because once you open it, you have to close it. Now you can do one of two things. You can either hit enter and continue on as a fraction, or you can hit divide and then put the number in at the bottom and do it all in one step. Let's do the first step first. We're going to hit enter. And because this is still a fraction, we're going to put our bar in. And we're going to get 8.39496 E29, which is 10 to the 29th power, over 6.02 times 10 to the 23rd. So now that you have that answer, hit divide, 6.02, second function, comma, 23, enter. And you get 139,000. No, you get 1,394,511.6 grams. You can also do it in one step. Open parentheses. 8.4 times 8.4, second function, comma, 27 times 99.94, close parentheses, divided by 6.02, second, comma, 23, enter. Gives you the same number. And we could equivalent this to 1.4 million grams. And this is the process for doing particles to mass multi-step conversion.